We're on Power Series Day 2, or Lesson 2. We've already looked at, Peter, what is a Power Series? Peter, what's a Power Series? Focus. It's more than just a small Ford sedan. It's something I need you to do. What is a Power Series? Not what is a Ford Focus. It is a series that has a what in it? An X. Good. An X. A variable. So the series, remember, is going to be a function of n, but it also has an X in it, which we treat as a constant when we're expanding it out. And the domain of a power series is the interval of convergence. Okay, so we looked at sine, cosine, e, some other ones that we didn't recognize the function for, but now we have geometric series, and we've already seen geometric series. So very quickly, if we look at a starting value of 1, and I told you that the common ratio is 2/3, we can actually list the series. The series could be 1 plus what would be the next term if the ratio is 2/3. What does that mean? That means to get the next term, we keep multiplying by another 2/3. So it's 1 times 2/3? 2/3, right? Plus the next term would be times another 2/3. What's 2/3 times 2/3? 4/9. There you go. Plus another 2/3 is going to give you 8/27 plus ... Okay, so that is a geometric series. Would that one converge or diverge? That one actually converges. Remember, we could write the nth term as 2/3 to the nth power plus ... And if you want to write that as a series, you can start with what value when you go to infinity? What value of n would generate a 0 when you plug it in for n to start with? 0, right? So we'll say it's the sum from n equals 0 to infinity. So there you go. It's just powers of 2/3. So this is not a power series. This would be your convergent geometric series. And remember, if we wanted to find the sum would equal the first term, which is 1 over 1 minus the ratio, which is 2/3. So this would converge to 3, as it turns out. All right, what if your ratio was negative 2/3? Well, the first term would be 1. The next term would be negative 2/3 times another negative 2/3 gives you positive 4/9. And then another negative 2/3 gives you negative 8/27 plus ... This one can be written in a very similar fashion. The sum from n equals 0 to infinity of negative 2/3 to the n. But it's also an alternating series, remember? Okay, it just so happens that if you have a geometric series with a negative ratio, it will alternate. So this one converges by the alternating series test. Because if you got rid of the alternator, which would be the negative 1 to the n, you're left with 2/3 to the n, which does go to 0 and decreases. But you wouldn't be able to find the sum by the alternating series test. But we can still find the sum of this one. Will this sum be bigger or smaller than 3? We're subtracting every other term instead of adding it, so it should be a smaller sum. The sum is still going to be the first term, 1 over 1 minus r. So remember, this will converge anytime the absolute value of r, which in this case is the absolute value of 2/3, but it always converges to 1 over 1 minus the actual r value. So that becomes minus a negative 2/3. So here we end up adding it. So we get 5/3 in the bottom, which is 3/5 in the top. So yeah, it converges, but definitely smaller than 3. So what if then I do the same thing, but now I let my first term be 1, and I let my ratio, my common ratio, be x. Well, the first term would be 1, and what would be the next term? You multiply by x, and you get x times another one, you get x squared, plus another one, you get x cubed, plus ... And this would be the same thing as it was above. It would be the sum from n equals 0 to infinity of our ratio, which in this case is just x to the nth power. And of course, if we want the sum is just equal to the first term of 1 over 1 minus the ratio, which is x. Okay? And of course, we then know that this thing converges when the absolute value of x is less than 1. Strictly less than 1. So that would be, if we looked at our interval of convergence, it converges on the interval from -1 to 1. And we don't even have to test the endpoints because we know it's kind of like exponential. When the base is 1 or -1, they're both going to diverge. So here you go. If you look at this in general for any x, you get the geometric power series. And we kind of mentioned this on Friday. 1 plus x squared plus x cubed is equal to 1 over 1 minus x. Now, if you think of the function 1 over 1 minus x, what does that graph look like? Or what can you tell me about the function 1 over 1 minus x? What is the domain of 1 over 1 minus x? All real numbers except 1. This function 1 over 1 minus x has a what at x equals 1? VA or a whole? It has a VA, right. If you want to look at this as a transformation of the parent function 1 over x, you would have factor out your negative, and it would be the graph of 1 over x that's scooted right 1 unit, and then the negative would reflect it across the x-axis. So instead of living essentially in quadrant 1 and 3, it would live down here in quadrant 4 and 2. So remember, when we write a power series to represent a function, it's typically a polynomial, although it doesn't typically have, it doesn't have to be, but this one is a polynomial. It's impossible then for this polynomial to represent the function 1 over 1 minus x for all real values, like it did for sine, cosine, and e, right? Because the function it's representing doesn't even exist for all values from negative infinity to infinity. In fact, we know that it is only going to model this function from -1 to 1. So if you were to look at the open interval from, let's do this, -1 to 1, you're going to be able to find a polynomial that perfectly, it can do something like this, but it's going to perfectly and completely represent the graph of 1 over 1 minus x exactly, but only on the interval from -1 to 1. So there's another kind of reinforcement of what it means to find the interval of convergence. It's the domain of the power series, the values of x for which the series itself, with infinite many terms, perfectly captures the terms of the function it represents. Okay, so I think we did this already on example 2. We found it by long division. So it's another way to kind of get the series for 1 over 1 minus x. But I think it's pretty easy to remember. This, in fact, would be pretty much the easiest one to remember, right? Of all 4 of them that you have to memorize. E, sine, cosine, and this one. We could easily turn this one into e, can't we? By doing what? What's the only difference between this power series and the one for e? We would just divide by the exponent factorial. Yeah, so 1 plus x squared over 2 factorial, x cubed over 3 factorial, that turns into e. Without it, this just becomes 1 over 1 minus x. So I'm going to skip example 2 because we did that on Friday. Okay, so what are you expected to do then on the AP exam? Well, you can modify this known series, okay, so that you don't have to reinvent the wheel or redo long division. For example, in example 3, it might tell you to find a power series centered at 0, which, by the way, ours is centered at 0, okay, because it's 1 plus x minus 0 plus x minus 0 squared. So it is centered at 0, and that's symmetrical on either side. Was that R2-D2? Yeah. Okay, cool. So what do we want to do? We want to develop a power series, or a Maclaurin series, really, for 1 over 1 plus x. So you could do one of two things. You can realize that this is something you can actually just do long division on, and you could generate the terms that way, and then maybe come up with the general term. Or if you can write this in some semblance to 1 over 1 minus x, you can make this look like that. You could do any of the things that we talked about before. You can substitute x with something. You can multiply through by a variable. You can multiply through by a number, and it's raining outside. Okay? So how can I write 1 over 1 plus x in terms of 1 over 1 minus x? Yeah, just call 1 plus x, just call it minus negative x. Would that be the same? Sure would, right? Because what is minus a negative? It's really plus. So if you want to come up here and start with your given geometric series, 1 over 1 minus minus x, it's 1 plus x squared plus x cubed plus dot, 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 plus x to the n plus dot, dot, dot. Now, how can I easily come up with the new power series for this function 1 over 1 plus x? Replace x with negative x, yeah. We'll just replace x with negative x. So I get a 1 minus x, and now it becomes a plus x squared minus x cubed plus dot, dot, dot. And if you want, you can write that as negative x to the n plus dot, dot, dot. And that's fine, because that's really what we're doing, right? But of course, the general term, if you had to like pick it out of like a multiple choice lineup, it probably would not be written like that. Because what they're probably going to do is, like we did last week, they'll split up the alternating part from the non-alternating part. Okay, so remember, it's really the same thing. So it's kind of what we just did up on part A with the negative 2/3, except here we have a negative x in general. So you don't have to use Taylor's theorem. Taylor's theorem would still work, but that would require a lot of work, right? Finding f prime, f double prime, f triple prime, and then plugging in 0. Long division would still work here, and it might be plenty fast enough, but long division is not going to get you the general term. Okay? So that was an easy one. Oh, it says to find the interval of convergence. What do you think the interval of convergence still is? Yeah, it's still the same thing, because if negative x is our ratio, this is going to converge when the absolute value of negative x, which is equal to the absolute value of x, is less than 1. And we know then by the same reason that the other one is it's going to converge from negative 1 to 1. So that's the interval of convergence. Non-endpoints, they're not included. Okay, what about on example 4? It says find a power series that represents x over 1 plus x centered at 0. You certainly don't want to reinvent the wheel. You don't want to do Taylor's formula. F prime, that's going to use the Hody-High rule every time. It would still work, but if you can write that as some modification of your known geometric series, you'll have it. Well, what would I do? I would first change my x to a negative x, like I did up above here, and then how do I introduce an x into the numerator? If I wanted to take this, let's import this from the line above, because that would really be the first step. You could actually write x over 1 plus x. You can write that as x times 1 over 1 minus negative x. And so what you've done is you've written it in terms of 1 over 1 minus something. That's the key there. If you can write it as something times 1 over 1 minus something, the blue highlighted part is your what? That's your memorized geometric series. So if I were to do it from scratch, the first thing I would do is, like from above, I would create the series for 1 over 1 plus x. I guess I didn't highlight it or copy it, which is this right here. Copy, paste. Oh, you know, it's not letting me paste because I need to delete some files. Okay. Go ahead and do that. See if you can still paste. My iPad is, yeah, there it is. It just told me my storage is almost full. So we'll record this. It's great. So take your answer from above and just multiply everything through by an x. And you should have it. I wonder how many it's going to make me delete. Maybe I'll go back to like 2,000. I do have a lot of stuff on here. All right, let's see if that was enough. Yeah, it didn't let me do anything here. Once I got out, it just got rid of it. It's not storing anything. So anyway, we would take our equation from right here. Let's just modify this one. And if I multiply everything through by x, let's just talk about it. The first term is going to be x. The next term would be minus x squared plus x cubed minus x to the fourth. So how many terms do we write? It'll tell you. Include the first 4 non-zero terms. So that's why I went out 4 here. And the general term. Well, the general term would be negative x. If I just wanted to say times x, that would be fine. But here's where splitting it up would be nice. Because if I just wrote the general term like this, negative x to the n times x, that would be fine, but I wouldn't be able to combine those because the bases are different. But by splitting up the alternator from the magnitude generator, then it could be like this, negative 1 to the n times x to the n times x, which would be to the n plus first. And that would be a prettier looking general term. But again, the reason that you want to maybe memorize the initial one is because it's easy to find the nth term. You could just modify the nth term in the exact same way you're modifying each term. Okay, let's look at this one. How are you going to do this one? Let's just talk about it. We'll save some time. How are you going to find a power series for 1 over 1 minus x squared centered at 0? This one's almost even easier. Do what? If I pull out a 1 over x, I would have to factor it out of both terms. What's really the only difference between 1 over 1 minus x and 1 over 1 minus x squared? It's squared, so I can just plug in, right? Like we did on 2 ago where we replaced x with negative x, we can just replace x with x squared. So let's go ahead and write out the one we memorized first. 1 over 1 minus x is 1 plus x squared plus x cubed plus yada, 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 x to the n plus yada, yada, yada. So remember, that's how you write the nth term, or the general term. And now, beneath there, we'll just replace every x with x squared. So I get a 1 plus x squared plus x to the 4th plus x to the 6th plus dot, 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 plus. And what is x squared to the nth power? If you want to do it like this off to the side. X to the 2n. Good. Plus dot, dot, dot. Sweet. So if you have like a ratio, like a polynomial looking thing divided by like 1 plus or minus something, or you'll see it doesn't even have to be a 1, you can modify your existing series from 1 over 1 minus x. And it's a little bit, maybe a lot a bit faster than for sure doing Taylor's rule, which will still work. Long division here would still kind of work, but it doesn't give you the nth term. Okay, let's do this one. 1 over 1 minus 2x, centered at 0. We haven't been answering the question in full. We haven't been finding the new interval of convergence, so let's do that one on this one. I can modify this one pretty easily just by replacing x with what? 2x. So let's go ahead and set it up. We'd start with 1 over 1 minus x, and it's kind of nice to have that one listed first because it's your reference one, plus x to the n plus dot, dot, dot. And now 1 over 1 minus 2x, you're going to get 1 plus 2x plus, if you want to square the 2 and call it 4x squared, that's fine. 2 to the third would now be 8x to the third plus dot, 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 dot. Now, if you do it that way, you're going to probably want to separate this as 2 to the n, x to the n. And that's how the multiple choice answer would probably be written. 2x quantity to the nth would be 2 to the n, x to the n. All right, let's go ahead and find the interval of convergence. And let's think about what happens here. If I replace in any function an x with 2 times x, what does that do to the graph of that original function? If you replace x with 2 times x. It's a horizontal stretch or compression? It's a horizontal compression by a factor of, in this case, 2. So that makes it narrower, right? So if it used to converge between negative 1 and 1, left to right, what do you think happens now? It should be negative 1/2 to 1/2. Let's verify. Without using the ratio test, this is another reason why you want to recognize it as geometric series. Your ratio, the absolute value of r, is really, in this case, the absolute value of 2x. Right? Whenever you can write it as 1 minus something, that something is your ratio. And by the ratio test, the geometric series test, that only converges when it's less than 1. Well, the center is still 0. So if I then divide both sides by positive 2, I can pull the factor of 2 out as long as I make it positive. In other words, this is the same thing. I can divide through by 2, and I get x minus 0 is less than 1/2. So I know that my radius of convergence is what? They might ask you that. It's 1/2 instead of 1. And let's say that you weren't sure if the endpoints worked. How did we test endpoints last week? You can test them the same way. You plug them into the nth term. But to do that, you want to write it in sigma notation. So let's do that. We would start at some n value, go to infinity, and we'll have 2 to the n, x to the n. In order to get a first term of 1, my n needs to start with what? 0, yeah. So now that I have it written in condensed form, I can test the endpoints. So if our center is 0, and I'm going plus 1/2 on this side, and minus 1/2 on this side, then my boundaries are negative 1/2 and 1/2. That's kind of obvious here because it's centered at 0. But let's test out the endpoints. When x equals 1/2, let's do that first. You're going to get n equals 0 to infinity of 2 to the n times 1/2 to the n. Well, that's the same thing as 2 times 1/2 to the nth power, which is 1. And does that series converge or diverge? Plus 1, plus 1, plus 1, plus 1. The series diverges, good, because the rule of sequence, the nth term converges to 1, which is not 0. So I cannot include 1/2. So I know my interval of convergence is going to be, for sure, 1/2 with the parenthesis. And now the question is, what about negative 1/2? Is it a bracket or a parenthesis? Well, we'll just do it again. We'll just say at x equals negative 1/2, we get the sum 2 to the n times negative 1/2 to the n, which if you split that up, that's the same thing as, it's going to end up being negative 1 to the n times 1, or just negative 1. You could bring that inside and call it negative 1 to the n. 2 times a negative 1/2 is negative 1. And that goes plus 1 minus 1, plus 1 minus 1. So that one also diverges by the nth term test. And because that one diverges, we cannot include the left endpoint either. So again, it's helpful if you recognize it as a geometric series. Because for a geometric series, we know that we're not going to be able to ever include the endpoints. Because the ratio has to be strictly between, originally, negative 1 and 1. So you can save a little bit of time on testing the endpoints and all that stuff, finding the radius, and modifying the existing. Now, the ones we looked at on Friday, those were totally non-recognizable. There you kind of have to go through the ratio test to find the radius, and then come back and test the endpoints separately. Okay, let's do number 7 here. Let's see if we can at least get it set up. Find a power series for 4 plus x centered at 0. Now remember, if we're going to modify it, we have to get it to look like 1 over 1 minus something. And it could be multiplied by something as well. So how am I going to do that? Well, yeah, I could factor out a 1/4 essentially. So if I start with 1 over 4 plus x, maybe I'm going to factor out a 1/4. Or just, would that work? Yeah, because I factor out a 1 from the top and it's a 1. If I factor a 4 out from the bottom, I'm left with 1 plus x/4. Does that make sense? Okay, so the 1/4 isn't going to be a problem. And now, of course, I have 1 over 1 minus negative x/4. And I've written it in terms of 1 over 1 minus something. So now we could create it. I would first start with your 1 over 1 minus x and replace your x first with negative x/4. It's going to be an alternating series again. And then once you have that, then go ahead and go through and multiply every term by 1/4. And you'll have it. And if you modify the nth term, it'll work nicely. Now let's quickly find the interval of convergence right before lunch. The radius of convergence, remember, because it's geometric, the absolute value of the ratio is the absolute value of negative x/4, which is positive x/4. And we want it to be less than 1, always. So if I multiply both sides by 4, I get the absolute value of x, or x minus 0, is less than 4. So what's the radius of convergence? It's 4. And because it's geometric, guess what the interval of convergence is, if it's still centered at 0? Negative 4 to 4, non-inclusive. There you go. So that's why recognizing it as a geometric series can be a huge time saver. All right, have a fantastic lunch.